Alright guys, welcome to the science world, and it's the mathematics doctor once again. Now in this video, we'll be talking about the electric field. And when we say the electric field, right, I can definitely say that the electric field is a region or space where interactions of charges tends to take place. And when we talk about the charge in here, we are talking about the electrons and the protons. And the electrons are always negatively charged, while the protons are positively charged. Now you notice in here, I actually say it's easy to lose the electron. That is, the electrons can be easily lost compared to the protons. So you can lose the electron faster compared to how far you lose the protons. And this is due to the fact that the protons are heavier in terms of mass than the electrons. So in terms of mass, the mass of the protons is way greater than the mass of the electrons. So since the mass of the protons are far greater than the mass of the electrons, it is easy to lose the electrons compared to the protons. But in terms of charge, the protons have the charge of 1.602 by 10 to the power of negative 19 coulombs. And this is also the same charge as that of the electrons, and the electrons also have 1.602 by 10 to the power of minus 19 coulombs. So you can notice that in terms of the charge, they are the same. But the only difference here is that the electrons are negatively charged, while the protons are positively charged. So that is the difference between the two of them. So the protons are positive, while the electrons are negative. But in terms of magnitude, they are definitely the same. That is, they are equal. And when we are talking about the protons and the electrons, the first concept that will come to my head straight away will be the atomic structure, right? And of course, in the nucleus of the atom, right, you know that the nucleus comprises of the proton and the neutron. And the proton, on the other hand, is positively charged, while the neutron, on the other hand, right, is neutral. Right, so in this case, or in the concept where we have this, right, we know that the protons are coming from inside the nucleus. Now, of course, around the nucleus or surrounding the nucleus are various shells, right, are various shells. So I can put that straight down here. I can put that straight down here, and of course cover each of that with some shells of orbits around it. Now the electrons tend to revolve around the nucleus, right? So in this way, the rotation at which they take place is then referred to, right, as the orbit in which they go around the nucleus. So the electrons revolve around the nucleus, and as the electron revolve around the nucleus, of course, there's an attraction between the nucleus and the electrons. And this is due to the fact that the protons, which are here, they are positively charged, and the electrons, which are here, right, they are negatively charged. So since the one is positive and one is negative, there tends to be an attraction force, right, between the proton and the electrons. So the protons and the electrons tend to attract each other with a force of attractions, right? So in this way, right, between the protons and the electron, there's an attraction. So the nucleus are attracting the electron. Now, in this concept, we can think about this entire concept as a very significant one. since we know that in the basic idea of an atom, right, we can have a neutral atom or we can have on the other end a charged atom. Now, if we have a neutral atom, what kind of atom do we say are neutral? Now, when an atom is neutral, we tend to believe it is having neither positive or negatively charged. That is, it is in the concept, or in a very, very simple concept, that this atom here, right, haven't lost or gained electron, right? That is, they maintain their nature. They maintain, I should say, right? I should say, their electrons are neither lost nor gained. So electron is neither lost nor gained. So they don't lose electron, neither do they gain electron. Thereby, they are neutral. But if an atom becomes charged, on the contrary, if an atom becomes charged on the other hand, right, we can say that an atom can become charged either by gaining or losing electrons. So they can either gain electrons or lose electron. So an atom becomes charged either by gaining electron or by losing electrons. So when an atom is charged, we refer to this concept of this atom, right, as ions. So in that way, if an atom should gain an electron or lost an electron, what will happen to such atom? And in that way, I can be able to move this all up for you now. Now we are having in here, we can have, for instance, sodium atom, which is having the atomic number or the proton number of 11. So mind you that the number here is also referred to as the proton number. And if the proton number is 11, which means we can significantly say that sodium have plus 11 charge, since it has 11 protons. And of course, from here we can tell that the proton, that the electron, that the electron in this case are also 11, but this time around that will be minus 11 coulombs. And I can take the total charge here, and that will give me 0. But if on the other hand, sodium should either lose an electron, which you know that sodium will definitely lose an electron. Why? Because sodium is a metal, right? You can try to dig up a lot of metals in your element concept, and in this way sodium is a metal, and sodium this time around lose 1 electron. So I'm going to lose 1 electron here, and now that sodium just lost 1 electron in this case now, right, sodium still have 11 proton. Sodium do not lose electron. If you remember from the concept here, we easily lose or gain electron, not protons. And in this way, the proton is still plus 11 coulombs. Why? The electron in this case now, right, is no longer 11, but is now minus 10 coulombs. Now we can add up this, right? And if we do this summation, we will get plus 1 coulomb. And thereby is the reason why sodium in its ionic stage is written as Na+, indicating it has lost 1 electron. Now there are other concepts as well I might have shown you, and I would like you to go and check before we wrap the video here, and you have to join us next to be able to pick it up from here. Is if I have calcium which is 20, and in this way, if it is neutral, the proton number of my calcium is going to be plus 20, and of course the electron number of my calcium is going to be minus 20. Oh, sorry about that. That's negative 20, right? And in this way, we have a general charge of 0. But how about if calcium have gained or lost electron? What do you think is going to happen to that calcium? Before you watch the next video, try to write your answer down, as we are going to be putting this answer on the next video. So how many electrons is calcium going to lose? But in this way, let us think that calcium is going to be losing 2 electrons. And I will explain that to you in the next video. See you on the next one.